This BPMN model contains an event-based gateway. At such a gateway, the process waits that one of several events occurs. The event that occurs first determines which path will be selected. In contrast to a normal exclusive gateway, the decision is not based on data, such as the value of an order, but on events. The process starts with capturing an order and sending it to the warehouse. Then the process waits at the event-based gateway which of the two events occurs first. If the order confirmation is received first, then the lower path is selected, in which the order confirmation is viewed. If, however, the time event occurs first, which means that one day is over without receiving the order confirmation, the upper path is selected and the warehouse staff is reminded of the order. After that, the process starts waiting again for either the confirmation to arrive or a second day passing by without an order, so that it's time for another reminder. Bonita doesn't have this event-based gateway, but we still can achieve the same behavior. The waiting for the two events has been moved into a called process. Because of the parallel gateway, the called process also waits for both events to occur. The difference to the event-based gateway: when the first of the two events has been triggered, the process still waits until the other event also has occurred. This is prevented by the two terminating events at the end of both parallel paths. The terminating event aborts the entire called process at once, so that it doesn't wait anymore for the second event. The control goes back to the calling process. How does the calling process know which exit to select at the normal database exclusive gateway? The called process contains a Boolean variable, confirmation overdue, which is set to true when the time event has occurred first. The value of this variable is returned to the calling process, where it is used in the conditions of the splitting gateway's exits. Now, an employee starts the process and enters a warehouse order. The warehouse staff receive a task to confirm this order. If this task is not carried out, after 1 day, or actually after 10 seconds in this demo, the requester receives a task to remind the warehouse staff. This is done by phone and confirmed in the task form. Now the process waits again. If the warehouse order is now confirmed, the confirmation is displayed in the next task of the main process. This process still has one disadvantage. If the remind task is already in the task list and then the confirmation arrives, the remind task still needs to be completed before the confirmation can be viewed, although such a reminder isn't necessary anymore. This has been solved in this example by moving the remind task into the called process. That means that the task is deleted by the termination event when the order arrives. By the way, this behavior, which in this case makes more sense, couldn't have been achieved just with an event-based gateway in the main process.